Welcome to The Explainer. Today, we're putting on our detective hats to solve a case, but it's not hidden in some dusty old office. Nope, it's inside a massive digital library. All the clues are right there, but to find them, we've got to learn the language that data speaks. Okay, so let's just dive right in. Picture this, a library with millions of books. How in the world do you find the one you're looking for? I mean, you don't just wander around hoping for the best, right? You use a system, a catalog. Well, in the digital world, that system is way more powerful, and it all comes down to how the information is organized. The secret, really, is something called a relational database. Now, I know that sounds a bit technical, but just think of it like this. It's a set of perfectly organized digital filing cabinets. You've got one for authors, another for books, another for all the readers. But here's the magic part. They're all linked together, which lets us ask some seriously smart questions. So, our case today is all about the data for a brand new library. And any good detective knows the first thing you do is review the case files. You've got to understand what you're working with. First up, our list of authors. You can think of this as our list of key persons of interest. As you can see, each author has their own unique author ID along with their name and birth year. That little author ID number? That is a crucial clue. You're going to want to remember that. Next, we've got the evidence locker, a table with all the books. Each book has its own ID, a title, a publication year, but look closely. It also has an author ID. This is the link. It's that piece of string that connects this book all the way back to its author in that first filing cabinet. This is how the database knows author ID 1 is J.K. Rowling. And here are the library patrons, our readers. Every single one has their own unique ID, just like the authors and the books. This table just tells us who's registered to use the library. Simple enough? And finally, we have the activity log, the loan records. This table is so cool because it uses the book ID and the reader ID to connect everything together. It tells us exactly who borrowed what and when. Oh, and see that null value? In detective speak, that just means empty or unknown. It's our big clue that this book hasn't been returned yet. All right, now that we've looked at the files, it's time to start the interrogation. Problem is, you can't just yell at a database. You have to speak its language, and that language is called SQL, Structured Query Language. It's our #1 investigative tool. We can start with a really simple request. This command, select all from books, it's basically us telling the database, hey, show me absolutely everything you've got in the books file. It's like dumping the entire contents of a filing cabinet onto your desk. It's a start, but it's messy. A real investigation needs precision. We don't want every single piece of information. We want the right piece of information. What if our case needs us to find authors from a totally different era? This is where a real detective earns their stripes by asking sharp, targeted questions. And this just illustrates the power of SQL so perfectly. It's pretty much a direct translation of our question. We select the name column from our author's table, and then we add a filter where the birth year is less than 1900. Simple, precise, and it's incredibly powerful. Finding a single clue is great, don't get me wrong. But a master detective, they see the bigger picture. They uncover the patterns that are hiding in plain sight across all the data. And yeah, SQL has tools for that too. Sometimes you just need a quick summary. We can ask, so how many books are actually in this collection? Using a simple function called count. As you can see, the command is super straightforward. The database runs it, and boom, it gives us the answer right away, 13. But what about a more complex question? One that requires looking at the data in groups. For instance, which author has written the most books in our library? We can't really answer that by just looking at one row at a time. So how do we answer that? Well, this is where a command called group by comes in. It is a total game changer. It tells the database to group all the books together by their author, and then it counts how many books are in each of those groups. And just like that, we get this really clear picture J.K. Rowling and Stephen King are tied for the most titles in our collection. Individual clues are valuable, but the real breakthroughs, those aha moments, they happen when we connect evidence from different files. This is where our detective work gets really fun, linking authors to books and books to the readers who check them out. The way we do this is with an operation called a join. Seriously, think of it as the master key that unlocks the whole database. It works just like a real detective would. You find a clue in one file, like the author ID in the books table, And you use that clue to find matching information in a totally different file, like the author's actual name. So let's move on and see how all of this builds to solve the ultimate mystery of our library. We want to connect everything: the reader, the book they borrowed, the author who wrote it, and when the loan happened. This is the big one. Now, at first glance, I know this command might look a little intimidating, but it's just a chain of those simple joins we were just talking about. We're telling the database, connect books to authors, then connect that result to the loans, and finally connect all of that to the readers. This one command pulls everything together to solve the entire mystery in one go. And just like that, the case is cracked. By learning to ask the right questions in the right language, you've gone from looking at a bunch of messy files to uncovering a complete story. You've learned the fundamentals of being a data detective. So here it is, your essential toolkit. These 4 key commands are the foundation of pretty much everything you'll do in SQL. You use select to look at the evidence, where to filter for specific clues, group by to find hidden patterns, and join to connect all the evidence. We've closed the case of the digital library. But the real question is, now that you have the tools to interrogate data, what mysteries will you choose to solve? The world is full of data, just waiting for a detective like you to come along and crack the case.